experiment is about spring mesh system. For the experiment, we have used different way and fixed the spring constant value.
Okay, for this experiment setup, we will need the weight springs. Our spring is constant, so we will use one spring, and this is the accelerometer and the accelerometer sensor. So to set up this experiment, we will need to screw the spring to the rod here, and then we will apply weight to the plate. To apply the weight, we'll need to apply force so that we will manipulate or control the vibration of the spring. That's all.
So I'm going to explain about Daisy Lab setup for our experiment. First, this input is from the sensor accelerometer, and then the first one is YT chart. So this one will display our raw vibration without any changes. So for the second one, we have used digital filter, which is low pass digital filter, to decrease the noises all and show our clear graph for the vibration. And then for the third one, we have used the same digital filter and then a FFT graph to convert the time based to frequency based graph. So from this graph we can find the frequency value, and from this graph we can find the time for the vibration. So that's all for our Daisy Lab setup for this experiment.
Okay, for the part A, we use the original length of stiffener spring and then set up with the load 30 Newton load like this. And then the spring after the mesh was applied was measured like this, and repeat the data with mesh 40, 50, 60 and 70, and all data are recorded.
Okay, I will explain about part B. So part B, we calculated the natural frequency by using Daisy Lab. So for calculate the natural frequency, we have to place the accelerometer sensor on the mass. So by this, the Daisy Lab will produce the vibration.
Good day to our vibration lecturer, Dr. Cheku Eddy. I am Madhiwanan, Analalaki and Tamilwanan here to brief about our result and discussion for our spring mesh system lab. So as you see, there are part A and part B for our experiment. For part A, we calculated the extension of the spring. So here's the result for the extension of the spring for 30 Newton, 40, 50, 60 and 70. And here's the extension of the spring for the respective weight. And for the part B, we calculated the natural frequency, experimental natural frequency using Daisy Lab, and then we calculated the theoretical natural frequency using the formula K/M, and then we find the percentage error for the between the natural and the theoretical. Other than that, for our results, we have also attached the time-based graph for the respective weight and the frequency-based graph for the respective weight together for more reference. And then for the discussion, we have brief about what we have done in part A and part B. So basically for part A, we have calculated the extension as you know. So we found out the initial length of the spring first, following by extension when 30 Newton weight is applied, and then we calculated the extension of the spring, how much it extend, and then we use the formula F equal to kx to find the spring constant. Then for part B, as I stated just now, we use the formula Z k over m to find the theoretical natural frequency and daisy lab graph to find the experimental natural frequency, and then we compare both of that. So that's all from us. Thank you.
Okay. As a conclusion for this experiment, we have finally determined the extension and also the natural frequency of the spring for different mass, and then we have also determined the decay rate of this vibration, and finally we have compared the experimental value with the theoretical value. That's it from us. Thank you.